Hello, everyone. My name is Stephanie Mehta, editor of Fast Company, and welcome to the Aspen Ideas Festival. This is a great conversation. I'm really excited to be helming it today. We are joined by Senator Mark Kelly, who is one of the most recognizable faces in Congress. As an naval aviator, he flew 39 combat missions in Operation Desert Storm, and as an astronaut, flew 4 missions into space. Now, he represents the state of Arizona, where our other panelist, Pat Gelsinger, has deep interests. Pat is the CEO of Intel, which has been innovating and investing in Arizona for 40 years. Pat is a 30-year veteran of Intel, but he also spent more than a decade at EMC and VMware, where he served as CEO before rejoining Intel earlier this year. Welcome, Senator Kelly and Pat Gelsinger.
Good morning, Stephanie.
Good morning, Stephanie. Great to be with you today.
Gentlemen, I think most Americans probably don't give much thought on a daily basis to semiconductors, but recent supply shortages have had an impact on a range of industries, from autos to appliances, and that's raised awareness of a key fact, which is that just a small percentage of semiconductors, 12%, are manufactured here in the United States. I want to start with you, Pat. We are the country of Silicon Valley. How did we get here? How did we get to manufacturing such a low percentage of global semiconductors?
Well, we are in a spectacular situation today, Stephanie. And, 30 years ago, we were 37%. And we've seen that steadily decline. And COVID has just put an exclamation point on this situation where demand was accelerating, then COVID happened, and the supply chains were disrupted. So all of a sudden, everybody knows about semiconductors, these little things, because the world is going more digital. And really what's happened is, the Asian countries have said, this is critical. We want this on our soil, and they've put extraordinary incentives, priority, national industrial policy to bring semiconductors to Asia. Been very successful. And all of a sudden we're seeing that, we're only 12% and we're going down. And that's caused us to say we have to change this pathway. And clearly, as I've come into the leadership role, we said we're going to step into this. And obviously, Arizona's played a critical role in that. I'm sure we'll talk more about that today. And we're seeing that we're going to do our part, but we need more. And for that, we're highly encouraged by some of the steps of the Biden administration, the Jobs Act, the CHIPS Act, that's it's called. And we're just so excited to see that we can change this curve, right? Declining for 30 years, we believe we can reestablish the leadership of the U.S. semiconductor industry, and we, Intel, want to play our part in doing that.
Senator Kelly, you've played an instrumental role in pushing some legislation that will help invest in American leadership in the manufacture and research of semiconductors. Why is this an issue for policymakers? Why is this not just an issue of a corporation needing to do more to increase its visibility and its investment in semiconductors?
Stephanie, it's because this is a national security issue. These semiconductor chips go in everything from your vacuum cleaner or your cell phone all the way up into the avionics of the most advanced fighter jets in the world, and the satellites that the National Reconnaissance Office puts into space, literally everything. And as we've seen, as Pat highlighted over the last year and a half with the pandemic, it's not too difficult for these supply chains to be disruptive. We saw that here from a public health emergency. They could be disrupted for other reasons as well. And as the manufacturing of the bulk of semiconductors have moved offshore, Pat highlighted that we went from 37% to 12%. And the number would continue to go down if we don't do something about it. To allow near-peer adversaries to grab market share, or even just to have these semiconductors manufactured in countries that we have good relationships with, but that could be threatened from near-peer adversaries, puts our national security at risk. So this isn't just up to industry to try to solve this problem. This is an issue for government. Let me also point out that we're at 12% now. If that number was to get below 10%. I mean, I've spoken to industry leaders and economists about this, that we would be at risk of losing other manufacturing businesses. Maybe they have nothing to do with national security, but they don't want to be in a situation where their supply chain for their semiconductors that go in in whatever they're selling that they wouldn't have access to it, so they would likely put their manufacturing facility somewhere else in another country. That means jobs here in the United States could be sent overseas.
I want to come back to jobs in just a minute, but Pat, let me ask you, if 12% is too low, what's the right share? You have a moonshot number in mind. What is it, and how do we get there?
Yeah, and clearly, as we think the Jobs Act, the CHIPS Act, is a great step to sort of flatten that curve. But our moonshot would be that a decade or so from now, that we'd go from 37 to 12 and back to 30. Right, and we think if we get to 30, and we've also met with our European counterparts as well, and they've dropped from 44% to 8%. Whoa, we've fallen a lot, they've fallen more, and their moonshot is 20%, to go from 8 to 20 over the next decade. And I think if we were sitting here a decade or so from now, and we were at 30% plus in the US, 20% in Europe, 50% in Asia, I think we would all be doing backflips and saying, wow, that is like this dramatic shift that really does create what I've described as a globally balanced supply chain. Where we're having good competition, good interdependence, and good choice across the globe for where this most critical piece of humanity resides. Remember, everything's going digital. Everything digital runs on semiconductors. Every piece of humanity, not just national defense, but every other portion of our lives, whether we're working from home, learning from home, health from home. That's all semiconductors. AI, cloud, edge computing, 5G, semiconductors. This is touching every aspect of our life. And I really see that 30, 20, 50 by a decade or so from now. Wow, that'd be tremendous.
Hey, Pat, how about we set the goal even higher? Let's get back beyond 37%, maybe to 40%.
Well, I do think if we get to that 30 point in a decade, and I think that's really going to be challenging, we're going to be on a curve that allows us to do even better than that in the next decade. And, speaking of moonshots with a astronaut, I sort of like that terminology.
Well, in the 1960s, we set a goal to land a person on the moon. We're really good at doing hard things, at innovating. When we put our mind to something as a country, which we're doing right here, I would say there isn't any goal that's out of sight. So I'm looking forward to getting to your 30% and maybe a little bit past that.
There we go.
Pat, not all microchips are the same. So, talk a little bit about the kinds of technologies that you would like to see the United States dominate as you march toward that 30% goal. There's got to be certain aspects of the industry that you would like to see the United States play a greater role in, and there may be certain kinds of microchips that don't make sense for the U.S. to manufacture. Can you elaborate on that a bit?
Yeah, and you'll hear language like modern nodes, trailing nodes, and leading nodes. And you can sort of think about that. The cool stuff where we do most of our business is on this leading edge capacity. And that to us is where the research, the R&D, where the critical aspects of defense would be. And we just say, boy, that is so critical for us that we must be a leader on leading nodes. Right? But we also see that, boy, there's a lot of other industries that don't need to be quite at the bleeding edge of technology, and this would be a lot of like the automakers, right, where we have to fill out and have supply chain resilience for them. And a lot of these trailing nodes, well, a lot of that, and we've seen this in our supply chain disruptions that we've dealt with through COVID, that we need to modernize those. So the CHIP Act, as it's been laid out, really is about manufacturing and helping to have those modern and leading nodes. It also is about R&D and research that we're going to be on that front end. And we're Gordon Moore, one of the founders of Intel, Moore's Law. As I say, 5, 3, 2, 1. Right? As we get to these very, very small nanometers and beyond. Right? And I say, Moore's Law isn't finished until we've exhausted the periodic table. And we have a lot of innovation to go as we get to 1 nanometer, right? And literally that's 10,000 times smaller than your hair. right? These are just extraordinary things. And if you visit one of these factories, as I say, it's really cool being an astronaut, but come to one of my factories. That's even cooler, right, to go into one of these advanced facilities. But then we also have to modernize many of these older semiconductors and bring them forward from trailing nodes as well. And it really is all three of those: advanced R&D, design services, but leading edge manufacturing. And if we bring all of those together as the CHIPS Act laid out, I think we've set ourselves on a path that we really have sustained leadership. And the country that created Silicon Valley, we're going to be back, setting the path for Moore's Law and semiconductors for the next several decades.
Senator, you had earlier talked about bringing really strong manufacturing jobs to Arizona. Share a little bit about the caliber of jobs that you think that increased investing in semiconductor manufacturing can bring. As you mentioned, these Intel facilities are state of the art. The kinds of positions and jobs that are created, it requires incredible amounts of training and skill. I've got to imagine that it's not just about primacy in the making of these chips, but also creating a new class of employees that can really grow and benefit from these kinds of high-tech jobs.
Yeah, that's right. And Pat and I have spoken about this, previously. And Intel is planning on investing billions of dollars in the state of Arizona. One of his competitors, a company called TSMC, they're going to build a fabrication facility in Arizona as well. They've announced 4,000 very high-paying jobs. These jobs do require significant training. In their case, they're planning on sending, at least initially, new employees that will be on the manufacturing floor to Taiwan for up to a year to get the training, and then they'll come back to Arizona. In some cases, my understanding is some have already made that initial journey to start that training. Their plan is for maybe up to 4,000 manufacturing jobs. Pat, it looks like if things go well here, we get the CHIPS Act fully funded, that he could be building more than another fabrication facility in Arizona. That's thousands of more jobs. Great for the Arizona economy. It's also great for the U.S. economy. But again, the most critical aspect of this for me, as somebody who is I'm the chairman of the Emerging Threats and Capabilities Subcommittee on Senate Armed Services, this is a national security issue. This isn't optional. I mean, if we do not get this done and bring this capacity back to the United States, we are putting our national security at risk. So this is one of my top priorities over my first 6 months in the United States Senate. It's going well. We've got to get this completely across the finish line in the House and to the President's desk for signature, get these facilities built, and then get to that 30% that Pat mentioned.
The other aspect of the jobs, Stephanie, to say, and we've done research that, as we put this, we'll, with the $20 billion that we've announced for Arizona, we'll be adding thousands of direct workers for us running those fabs. But it also, for everyone that we're adding in the fabs, we end up with a construction worker as well. These are very advanced facilities, so it's great construction jobs as well, plumbers and concrete and electricians. But for every job we create, our studies show that there's 7 to 10 jobs created in the community as well. Other suppliers are building facilities, schools coming around, restaurants and everything as well. So, for these facilities, it really just creates not only the education, leadership, technology that Senator talked about, but it really causes an entire community to build around it as well.
Senator, you talked a little bit about getting things over the finish line. Obviously, the effort to create the act was bipartisan. What are the objections? What are the things that you need to overcome in order to get it passed in the House, get it to the President's desk? What's the argument against greater investment in microchip manufacturing in the U.S.?
Well, we had broad bipartisan support in the Senate, and the bill passed with more than the 60 votes that we needed. And I've worked with Republicans and Democrats to make sure everybody understands that this has national security implications, that we can't continue to fall behind. We've got issues with our near-peer adversaries, China, that they are, in some cases, hypersonics being one, getting capabilities that we're starting to see we're falling behind on. And having the most advanced semiconductors is a critical aspect, whether it's hypersonics, artificial intelligence, quantum computing. We need to have this capability. So to get this passed in the House, I think it's going to get broad bipartisan support as well. As you know, the House of Representatives, this is true for the Senate, might want to make some changes to the legislation, and then we'll have to meet in conference committee and work out those differences and vote again. So it is a process. It takes some time. But I am going to continue to work now, not with U.S. senators, but advocate for this legislation with members of the House of Representatives that I have relationships with on both sides of the aisle.
Pat, we've talked about the role of government and policymakers in all of this. We've talked about the role of the private sector. As we think more broadly about U.S. competitiveness in tech, and the senator has mentioned quantum computing, AI, supersonics, there's a number of areas where we're seeing huge investment from countries like China. We haven't talked much about education. We haven't talked about some of the other legs of the stool. What do you see as the challenges that the U.S. faces in maintaining tech primacy more broadly, not just in chips, but in the things that we've dominated for so many years?
It does include what we call the National Semiconductor Technology Center, right? Because it starts those fundamental research, finding the edge of physics. And as I say, until the periodics table is done, we're not done, right? We're going to keep exploring and so on. But, that then needs to be complemented by the software, right? The algorithms, right? These other areas of usage, like AI, like quantum computing, et cetera. And it's humorous that we call it Silicon Valley, but there's far more Software Valley than silicon in the valley today, right? And if we start at the foundations of research, then you build up from that and you create the spiral of innovation. And I've called it the 4 superpowers of cloud, AI, edge, and connectivity. And, a couple of years ago, we were very appropriately concerned around 5G and what was happening with China and Huawei. Well, today, we've cracked that open with the magic of silicon and software, right? And as we're seeing key standards emerge. So all of it, we have to be exploring all of it. And that's why I'm so excited about what we're seeing in this particular effort right now, because it spawns not just manufacturing and chips, but it's going to spawn research. That research then, is going to feed new software, algorithmic work that's going to open up new uses in other areas. And we need to see the supply chain of those from the most advanced research and, pushing upstream, keeping our world-leading universities world-leading, making sure that we have the right visa policies. If you want to send us your best and brightest, please keep doing so. We want them and, working for us, and then spawning industries and startup communities that build on these foundational technologies. This is a spiral that we know how to do, and we've been doing it for decades, and we're going to do it again.
So Stephanie, part of this plan also includes this microelectronics network for research and development. And we're going to place there will be universities as part of this network where the basic research is done, new materials, often from the periodic table, but to get us to the point where we, on U.S. soil, will be manufacturing that first 1 nanometer chip. And even beyond that, and coming up with new ways to manufacture even smaller and smaller circuits and transistors. And so this is really exciting. I've been spending a good amount of time talking to Arizona State University about this. It's a possibility that part of this network would include ASU to do that research and development. It's ideally located in Phoenix, so it's close to where these fabrication facilities are. This will also allow us potentially to be able to test chips currently. As semiconductor chips are tested, we often send them to foreign countries, sometimes to our adversaries, as we do what's called this fab to lab testing process. Not an ideal situation. It would be better for us from a national security perspective to be able to manufacture and test, and then get these chips into the supply chain all here at home.
Senator, a lot of executives and leaders in the technology community feel like their lawmakers in Washington don't understand tech, that they really don't have a full grasp of the complexities of what it is that technology companies do. You've obviously communicated a really strong understanding, certainly of the semiconductor industry. But do you think there's some truth to that? Do you think Washington needs to spend more time really understanding the complexity of these issues, not only from a commerce perspective, but as you've pointed out repeatedly, there are national security issues at play here?
Well, yeah, of course. There's 535 members of Congress, come from all different backgrounds. A lot of lawyers, folks from business backgrounds. Some of us come from the military. I have a very, tech background. I've got a degree in marine engineering, a master's in aeronautical engineering. I've been an operator, as in working in the space industry as a pilot and commander of the space shuttle. So, I embrace this kind of stuff. I mean, this is part of my former life. That's not true for some folks. And if it isn't, they got to drill down and study the material and make sure they understand, why this is important. My job, and I look at this as, one of my roles because of my background here in the United States Senate, is to help, educate some of my colleagues that don't have this kind of background on why this is important.
And I would also say, Stephanie, that I think this is part of our job. The CEOs, the tech leaders as well, because many lawyers and business owners who've now taken on these roles of political leadership for our great nation. Boy, it's our job to come and help educate them, come alongside. We're not over here just running our business. It's part of our responsibility to come in and help them form the understandings and really bridge between the national requirements, the social requirements of our political leaders, and bringing the technology and industry perspective as well. And over my 100+ days here as a CEO, I've been spending a lot of time doing that. It is that important, and it's our job to go help bridge that level of understanding.
Pat, because of where you sit in Silicon Valley, but because Intel also has really good intelligence about what is happening with cybersecurity threats, with national security threats, from your point of view as a CEO, what are the things that keep you up at night when it comes to national security and these kinds of threats?
Well, this topic is top of mind for me. Right, in that respect, that recovering our industry's leadership in this area, I just can't imagine anything more important. Because if we don't have the fastest computers, we're not going to have the best cyber, which doesn't allow us to have the best security. It's that simple, that these things must build on each other. At the same time, our policies need to be, we can't disengage from China. This is the second largest technology market in the world. Right? Which means, I have 26% of my revenue in China. I need to find that right balance between continuing to sell, to continue to support their digital objectives, even as we're very thoughtful on how we sustain long-term leadership for American technology. It requires a very carefully thought out policy view. And blunt instruments don't work. You can't just say, we're going to have two worlds. One that we participate and one that they participate in. We need to find that right level of policy, that right level of export control that allows us to continue to be the supplier of technology to the world, even as we help to secure our long-term leadership positions.
Senator Kelly, we started by asking Mr. Gelsinger to share his moonshot for semiconductors, and you pushed that a little bit. You said, let's go beyond 30%. What is your vision, or what's your moonshot vision for, American technology?
Well, assuming we get this done, and I'm pretty confident we will, and we get these fabrication facilities constructed and get them producing the best semiconductor chips in the world, it's going to allow us to make technological advances in other areas. Artificial intelligence, quantum computing, quantum communications systems. The University of Arizona is, working on, that technology. The thing that keeps me up at night is thinking about the scenarios where our adversaries make technological leaps that we have not yet made, and that puts us at risk, puts our families at risk, our country at risk. So we've got to stay ahead. We are the best country in the world by far, traditionally, throughout history at innovating, inventing new technology, inventing new industries, innovation. We're really, really good at it when we put our minds to it. What we need is, we need good semiconductors. We also need the best education system in the world. We need to train more scientists and engineers and PhDs. We're generally good at that. Sometimes, for a period of time, we might fall asleep at the wheel. We've got to get back on track. We've got to stay ahead. China's graduating more scientists and engineers than we are right now. I still believe because of our system and our democracy and our, culturally, we've got folks that are really good at innovating. We've just got to keep our foot on the gas here.
Innovation is music to my ears. Thank you both for your time today. On behalf of the Aspen Ideas Festival, I want to thank Senator Mark Kelly and Pat Gelsinger, CEO of Intel, for joining us for this conversation. Thank you both.
Thank you.
Thank you.